Hello, my good people. Welcome back to my YouTube channel or the Big Structure Hub. This is a place where you learn, build, and innovate. Today, I want to solve problem under moment distribution method. And the question is on the board, as you can see. So the question reads, use moment distribution method to analyze the frame provided below. Hence, draw a bend moment diagram indicating values at all critical points. So the question carries 20 marks and the question comes from a past paper. So this is the frame, as you can see. The frame is loaded with both a point load of 15 kilonewton and a UDL of 8 kilonewton per meter. Again, the frame is fixed at point A and supported on a roller at point C. Again, it is fixed at point D. The EI or I is constant. It is loaded with 15 kilonewton placed at 2 meters from point A, and then again 15 kilonewton placed at 2 meters from point B, and then a UDL of 8 kilonewton per meter spanning at 4 meters. So let's see how we can handle such a question. Solution. So the first thing to do is to start calculating fixed end moment. So fixed end moments. So we'll start at point A. At point A, we'll have moment AB moving in anti-clockwise direction. So we'll have MF AB moving in anti-clockwise direction. So we will write our formula as minus because the moment is moving in anti-clockwise direction. And then open the bracket. The formula will be WAB square over L square plus WA square B over L square. We have a point load of 15 kilonewton. Again, a point load of 15 kilonewton. So this 2-point load will result into two formulas. As you can see, WAB squared over L squared plus WA squared B over L squared. So let's proceed. Equals to minus, the first W is 15 times A. A is this distance from here to here, which is 2 times 2 times B, this distance from here to here, which is 4 over the L. L is 2 plus 2 plus 2, 6. 6 square, like that, plus the second W is 15 times A. The A here is this distance from here to here. So, no, the A is this distance from here to here, which is 4 square times B from here to here, 2 over 6 square, like that. And then you can use your calculator to get the final answer. The answer is 26.67. 26.67. So we'll have negative 26.67 kilonewton meter. So that is our MFAB, fixed moment AB. We proceed to this fixed end moment, which is BA. So BA will be moving in clockwise direction. So the formula will be MFBA is equal to plus, why plus? Because the moment is in the direction of clockwise. You open the bracket, W A B square over L square plus W A square B over L square. So this will be plus W is 15 times A. A is 2 times B square, 4 over L square, which is 6 square, plus W 15 times A from here to here, which is 4 square times B 2 over 6 square. So our final answer will be plus 26.67 kilonewton meter. That is our MFBA. We proceed to BC, BC. So this is BC. So this moment is moving in anti-clockwise direction. So our formula will be minus WL squared over 12. So this one will be, the W is 8, minus 8 times L, which is 4 square over 12. So our final answer is, you can punch your calculator, minus 10 minus 10.67 kilonewton meter. We proceed to MFCB. This one, MFCB, because the fixed end moment is moving in a clockwise direction, so our formula will be plus WL squared over 12. Again, we take 8 times L, which is 4 square over 12. So the answer will be plus 10.67 kilonewton meter. We proceed to MF. MFBD will be equal to MFDB, which is equal to 0 kilonewton meter. Why 0? Because there is no loading along this span. After that, we proceed to stiffness factors. Stiffness factors, which is K. So for stiffness factors, we will consider a joint B. So let's consider joint B. Joint B will have KBA, which is equal to KBA, the farthest end of this span. As you can see, the farthest end is A, and the A is fixed. So our formula will be I over L. So because I is constant, we'll write 1 over L. The L is this distance from A to B. So 2 plus 2 plus 2, 6. So that is our KBA. We proceed to KBC. KBC will consider the farthest end of this span. So the farthest end is C. As you can see, C is a roller. So the formula will be 3 over 4 IL. So 3 over 4 times I. Our I is constant, so it will be 1 over L, 4. So this one will be 3 over 16. We proceed to KBD. KBD, as you can see, our farthest end, which is D, is fixed. So our formula will be I over M. So again, our I is constant. So our I is 1 over L. From here to here, 6. So that is our KBD. After stiffness factor, we'll proceed to distribution factors, DF. So again, we'll consider joint B. Joint B. For joint B, we'll have DF, DFBA. So DFBA, our formula will be K BA over K BA plus KBC plus KBD. So KBA is 1 over 6. 1 over 6 over 1 over 6 plus KBC 3 over 16 plus KBD 1 over 6. So our final DF will be 0.32. 0.32. We proceed to DF. DFBC. So DFBC will be KBC over KBC plus KBA plus KBD. So this one will be KBC 3 over 16 over 3 over 16 plus KBA 1 over 6 plus KBD 1 over 6. So our final DFBC will be 0.36. We proceed to sorry, we proceed to DFBD. So DFBD will be K BD over K BD plus K BA plus KBC. So this one will be KBD is 1 over 6 over 1 over 6 plus KBA 1 over 6 plus KBC 3 over 16. So our final DFBD will be 0.32. So for us to be sure with our distribution factor, we will add all these distribution factor for joint B. So it should add up to 1. If not 1, then you have made a mistake. So you have to correct your mistake. So let's see. 0.32 plus 0.36 plus 0.32 is 1. So our distribution factors are very correct. We proceed to table. So this is our table. As you can see, we have joints, member, distribution factor, and the fixed end moment. Under joint, we have joint M, which is this one. Joint A, it has member AB, as you can see. Then we proceed to joint B. Joint B is this one. It has member BA. BA. Then BC, this one. And then BD, this one. We proceed to joint C. Joint C, it has only one member, which is CD. And also joint D, it has only one member, which is member DB. Like that. So distribution factor and fixed end moment we had calculated earlier, and this is our values. So you just pick what corresponds to member and insert in the table. So we have AB, our distribution factor is 0. AB, because it's 0 because it's a fixed end span. So here is 0. Right here 0. We go to member BA. So BA, our DF is 0.32. You put it there, 0.32. BC, 0.36. You insert in that box. BD, 0.32. You put it there. CB is 1 because it is a roller support. 1. DB, 0, because it is a fixed end support. We proceed to fixed end moment. So for AB, we have negative 26.67 is there. BA, positive 26.67. BC, negative 10.67. BD, 0. CB, positive 10.67. And then DB is 0. So after you have inserted all the values you have calculated. Now you can start balancing this frame. So as you can see, we have this support C. Support C, it is a roller. So we will release C. So how are we going to release C? So here we have our fixed end as 10.67. So you will take any value that if you add or subtract 10.67, it will give you 0. So automatically that value is the opposite of this positive 0.67. So it will be negative 10.67. So if you add these two, you will get 0. Your answer will be 0. So after doing so, you will carry over this value, a half of this value, to the opposite member. So the opposite member is BC. So you will carry a half of this value to the opposite member, which is BC. So you take negative 10.67, negative 10.67 divided by 2. So the answer is negative 5.34. Negative 5.34. Like that. After doing so, you will now calculate our initial final moment. So our initial final moment will add fixed end moment as you proceed downward. So we'll start with negative 26.67 plus nothing, plus nothing, plus nothing. So our answer will be negative 26.67. 26.67 plus nothing, plus nothing. So 26.67. And then negative 10.67. Negative 10.67 plus minus 5.34. So the answer is negative 16.01. Negative 16.01. 0 plus nothing, 0. So positive 10.67 plus negative 10.67, 0. 0 plus 0 plus 0, 0. Like that. So after there, now we can balance B. Balance B. And we'll balance joint B because joint B, it has more than 2 members. That is member BA, member BC, and member BD. So for this joint B to be in balance, the total sum of fixed end moment for these members should equal to 0. That is to say, if you take 26.67 plus minus 16.01 plus 0, your answer should be equal to 0 for this joint B to be in balance. And if not 0, it means this joint B is not in balance. So you need to balance it. So let's do it practically. You take 26.67 plus minus 16.01 plus 0. I will show you the answer. So as you can see, the answer is not equal to 0. So it means that joint is supposed to be balanced. So to balance this joint, you'll change the sign of this value you have obtained. So our value is 10.67. It's positive. So if you change the sign, it will be negative 10.66. So you take negative 10.66 and distribute it equally to these members by multiplying it with distribution factors of each of these members. So for example, you take negative 10.66 times, we begin with 0.32. 0.32. So our answer is negative 3.41, as you can see on your screen. So you write it there. You proceed again to 0.36. So you take negative 10.66 times 0.36. So our answer is negative 3.84. Negative 3.84. We proceed to the final one. So the final one, our answer will be the same to the first one because they have the same distribution factors. After that, we will carry over a half of these values we have obtained to the opposite member. For example, we have member BA. The opposite member of BA is AB. So you take a half of this value to the opposite member, which is AB. So negative 3.41, you divide by 2, you will get negative 1.71. As you can see on your screen, again, we come to BC, half of BC to CB. So for this one, you will not take half of this value to CB because you have already released this joint, which is C. So joint C, as you can see, is a roller support. And for a roller support, the moment is always equal to 0. So if you take half of this to this member, you will be interfering with this moment, which is 0. So you just leave it like that. We go to this value, which is negative 3.41. So it is for member BP. So the opposite member will be DP. So half of this to this. So it will be negative 1.71. And then after that, there is no any other joint to balance. So you will get your, or you will calculate your final moment, and you will start from the initial final moment as you proceed downward. So we begin from negative 26.67 plus nothing plus minus 1.71. You'll get negative 28.38. We come to this one, positive 26.67 plus minus 3.41 plus 0 or nothing, you'll get positive 23.26. We proceed to this one, negative 16.01 plus minus 3.84 plus nothing, you'll get that one. And then 0 plus negative 3.41, you get this one. For this, you will have 0 and negative 1.71. And then after that, what follows next is to draw our BMD diagram, which is bending moment diagram. So let's see how we're gonna draw our bending moment diagram. So I will rub the board to create space for more calculation. Free span moment for this frame, and then draw the free span moment diagram, and then from there we'll combine free span moment and our final moment we calculated from uh, or we calculated in the table. So as you can see, this is our original frame. So span AB, it has two loadings, which is 15 kilonewton, 15 kilonewton, spaced at 2 meters each. So we'll calculate a free span moment for this loading, which is 15 kilonewton. So the formula will be WAB over L. So our W here is 15 and A is this distance from here to here is 2 times B 4 from here to here over 6. You get 20 kilonewton meter. Again, we calculate our free span moment for 15 kilonewton. So it will be WAB over L. So our W is 15. A is this distance from here to here, which is 4. And then B, 2. So over 6. The answer is 20 kilonewton meter. After that, we'll scope this section from A to B and draw it here. So this is A and this is B. So we'll draw our free span diagram for AB, which is 20. As you can see, this is the baseline. So from here to here is 20. And then you connect the line to form a triangle. Again, we proceed to 15 kilonewton. So you'll approximate from here to there. So 20 kilonewton meter, and then you connect the line to form a triangle. So for us to draw our free span moment for this span AB, we will need this distance y from here, this distance y, and this distance x, because this distance y will affect this 20 kilonewton meter. So if you get or obtain distance y, you will add to 20 kilonewton meter to obtain the final height. Again, this x will affect this 20 kilonewton meter. So you will obtain this distance x and add to 20 kilonewton meter to get the final height. So we will use similar triangle rules to obtain distance y and distance x. So for similar triangle, you will say y, you will compare y with this distance, which is 20, is equal to, you compare from here to here, that is 2 over from here to here. So that is 2 plus 2, that is 4. So mathematically, you carry out the operation to obtain y. So 4, y is equal to 40 over 4 over 4, which imply y is equal to 10 kilonewton meter. Since these things is symmetrical, this and this are symmetrical, so therefore also distance x is equal to 10 kilonewton meter. So you will take 20, this is 20 plus 10 to obtain the final height. So this is 30 kilonewton meter. Again, 20 plus 10 to obtain the final height, you have 30 kilonewton meter. After that, you can draw our free span moments diagram. But before then, let's calculate our free span moment for BC. So span BC. This one will be W L square over 8. So this one will be 8 times L, which is 4. 4 square over 8. So this one will be 16 kilonewton meter. So after obtaining those values, we can now draw our free span moment diagram. Now we can draw our free span moment diagram. So at our first 15 kilonewton, we had 30 kilonewton meter. So we'll approximate and draw an inclined line. So this is 30. Again, at our second loading, we had again 30 kilonewton meter. Again, we approximate and draw an inclined line. So this is 30. So at this point, we'll join a straight line. So that is our first. This one should be at the same level. Like that. So our second free span moment diagram will be at 16 kilonewton meter. So we approximate. So this one will be a parabolic curve. So this is 16. 16. After doing so, we can now draw our BMD diagram. So if you can go to our table, you will see that at A, B, we had negative 28.38. So we approximate along this line to get our values, which is negative 28.38. So it is below 30. So negative 28.38. It's not necessarily right negative. After that, we had B at 23. BA at 23.26. 23 23.26. No, 19.84. 19.84. That is negative. And then at C is 0. So you will draw a line joining this point like that. And then here you draw a curve like that. Again, we had BD as negative 3.41. As negative 3.41. So negative 3.41. And DB as negative 3.41. So this one to here, 3.41, and we shade our respective areas for visibility. So this is minus, this is plus, this is minus, and here plus, and here minus. And our question ends there. So if you have not subscribed to my channel, please subscribe and hit that notification bell so that you may be the first person to be notified when I upload a video. Again,